Hello, everybody. One of your assignments is to look ahead to lesson 3.2 so we can get a head start on this topic. And so you should have your note sheets out. Section 3.2, measures of dispersion. Sounds really complicated, but it's a pretty simple idea. So have your note sheets out. You're going to reference the book. I'm going to go through a little bit of this for you, but you're going to use your book to kind of finish this up. So you have your note sheet, and then the first thing I want to show you is an example of what measures of dispersion are. And so I want to show you what that looks like as a picture. So for example, what we're talking about in the last lesson, we talked about measures of center, which is mean, median, and mode. In this lesson, we're looking at measures of variability or dispersion. And it's how spread out the numbers are. Let me just show you what that looks like. For example, look at this dinner party here. It looks like everyone's kind of the same age, and we would say they kind of have their measure of center is kind of about would be their average age. And then looking at this one here, this is more of a picture of a family. And if we look at how old people are there, you see variability. You see a lot of different ages. If you look at this one here, they're older people, but they all have about the same age, so there's less variability. So that's what we're talking about. We're going to look at numbers and how numbers, are they close together or are they far apart, as opposed to what is the average or median of them. And so that's what we're looking at. So if someone asks you, what's the average age here? You might say 30, because everyone's kind of the same age. And if someone said, what's the average age here? You might say 30 also, but I see some children. I see some older people, see some middle-aged people, and so the average still could be 30, but there's more variability. So that's what we're talking about with numbers. So for example, there's ways to measure variability, and so one of the ways we measure variability between numbers is with range, and another way is it's going to be called standard deviation, and then another way is variance, and that's what we're looking at in this lesson with your notes. You're going to be referencing, when you do this, you're going to be referencing the textbook, page 131 through 139, to kind of get some of those examples done, and then also the definitions that we have there. So again, that's what you're going to do for finishing the chapter 3.2 note sheets. And so a quick example that's not on your paper, just to show you again. So for example, if I give you 5 numbers and say, okay, 10, 20, 30, 40, and 50, and then I give you another set of numbers, I would say let's go with 28, 29, 30, 31, 32. And then if I ask you the question, what's the average for this one here? We would say the average is 30. And on this one here, if I say what's the average here, we would say the average is 30. It's the value right in the middle. However, when we look at the two sets, we would say the first set, the one in black, has more variability. There is more dispersion. And so that's the language we would use for that. This set here has more dispersion compared to this one here. Right, this set here has less dispersion. They're closer together. They're closer to the mean. These numbers are farther away from the mean. And so that's what we're talking about. And so we measure that, and we're interested. And we'll talk more about that in class. But I want to make sure you get these notes done. So the first one we're looking at is you want to make sure you take care of this first definition here. This first one, again, is in line with what we have in the textbook. So if we look carefully here, we're going to use the range, and so you would go here, the range, and it has an equation for that. It's the largest value minus the smallest value, and that's one way to measure dispersion. And then you have an example here. This example is what matches up with what we have over here, and so you can calculate range. So you go ahead and do that. Okay, and then let me go on to the next one. You could pause this video and then do that and take care of it, but I want you to take care of that. Another way that looks definitely more complicated is through what's called the standard deviation of a variable from raw data, and you have all this information. So again, you can see from your notes, if you go into, or you go from your book, standard deviation. And if you look carefully, what it's measuring is how far away from the mean, right? How far away. The standard deviation is based on the deviation for the mean, how far away the values are. It's a complicated formula. Here it is. And we do calculate for um, standard population and for samples. But it's very complicated. We will use StatCrunch to do that. We're not going to do that by hand. We'll use StatCrunch, and you can find the instructions there how to do that. But so referencing your note sheet, make sure you're going to put in the standard deviation. This is the population. Make sure you get the correct set. But again, this is the formula, but it is definitely it's definitely, again, a complicated formula that hopefully it's easy to understand, but we're going to use StatCrunch. We'll talk in class about this, but it's interesting to try to answer. If a data set has many values that are far from the mean, how is the standard deviation affected? Well, the standard deviation measures how far values are from the mean. So if they're very far, then the standard deviation is going to have a large value. Okay, so we'll talk about it in class, but I want to make sure you make a note of that in this case here, and again, I want you to read the book a little bit so we can have this conversation. The standard deviation will have a large value, so I want to make sure you're good with that. Okay. The next one is for the sample standard deviation, and again, a complicated formula. Make sure you look at in the book for that. There's some questions here that for sure, once you guys get that out, we can talk about that in class. Is the standard deviation resistant? And so we'll talk about that, compare that to the mean and median, the mean, median, and that conversation on 3.1. And so when comparing two populations, what does a larger standard deviation imply about dispersion? Hopefully you can answer that. Try to answer these questions, read the book, and so we can get a head start. And we'll have the conversation. So that's what I want you to do for 3.2. This part will be the variance, and that'll be, again, an example in the book I want you to get down. Determine the variance. And so we can see that one, again, is in the book also here. So you want to make sure we get that. I don't think it's there. What page is that? That's page 136. There's your interpretation. And I think it's going to be 138 is the question. There it is, variance. And that's what you would fill in on this last example over here. Or what's the variance? And then you could do that last example. And then you're going to, you would go ahead, and after you look at that example, you can answer that question there. A very important topic, standard deviation is important, but there's going to be something called the empirical rule. We did that in Math 83. If you took Math 83, it's the empirical rule, so we're going to revisit that, and it becomes an important rule to understand and be able to draw this out. So that's where we'll leave off. That's what we're going to pick up in class on Thursday. So let's go ahead and make sure you get caught up, and you'll see this example matches up with this right there. And then what we're going to try to do in class, so I'll show you guys how to answer these questions. That's what we'll start off with. That's it. Thank you guys. Bye.